Okay, so these example 1 and 2 are a little bit easier than what's usually on the AP exam, but I have seen them on the AP exam pretty much this easy. Sometimes they'll throw in like one more piece of information, try to that's not actually something you need, just to try to confuse you a little bit. But we are given f of 3 equals 8, f prime of 3 equals 5, and we're supposed to find f inverse prime of 8. So that formula is what we're going to use. So Thomas, you and who else left yesterday? Margaret and Chandler missed this yesterday. All right, so this formula, Thomas, you want to make sure you got it down. It's a little prettier with G's, but I'll be honest, the G's kind of confuse me a little bit. But if you want to use a G instead of F inverse, you can. But yeah, the notation is bad. It's difficult on this. Okay, so this is a prime right here. So what this means is the derivative of the inverse of F. And so if you missed yesterday, you can watch the video for further explanation on that, or I still would like for you to watch the video, but I would generally just accept this as truth without questioning it, and blindly follow. So I promise it's right. What? Oh, yeah. Every time I have to listen to my YouTube videos, I think, oh gosh, this is awful. Especially like whenever I'm actually teaching class, because I'm not like even trying to like regulate how loud I'm talking or. Yeah, and then I'm like fussing at people or So all right. Hello, Addison. We're talking about you, and they think it was funny that I fussed at you yesterday. All right, so.
Why did you get yelled at? He was saying no words.
He was just, I've realized that saying something sick is kind of a good thing to say, because, like, I don't know if you mean it's good or bad, and nobody else knows whether you mean it's good or bad sometimes, because I'm pretty sure y'all are using sick as good and bad, so you can just like, if somebody is against you saying it was sick, you can just say that sick meant good in that case, and if somebody's against you saying that it was bad, you can just say, you can just flip your meaning there. No one even knows.
Our use of sickness is so out of pocket that it is entertaining to watch somebody else be out of pocket. Yeah. That is I enjoy seeing out of pocket things. Yeah, it's so funny. It's so good. Like just being unaffiliated. It's literally just dramatic irony.
Yeah.
Yeah, like the dude being Kermit a corn dog.
Okay, we're way off track. Okay. Okay. Back to some math. Regain your composure. All right, so in this case, we are finding the derivative of the inverse at 8. So we did do a little bit of that. But on this, you can't find the inverse here. So this x right here is going to become an 8. Okay. All right, so the first thing we need to find is f inverse of 8. That would be 3. Because the inverse has nothing to do with the derivative, so you do not look at the one that says f prime. And in an inverse, like f of 3 equals 8 tells us that f is the function that when you plug in 3, you get 8. The inverse is the function that goes back. So 8 is the y in the original function. 3 is the x in the original function. So we're finding f inverse of 8. We're looking for where the y is 8. And the answer is going to be the x that goes with that. So f prime of 8, or f prime of, we'll have f prime of 3. And what is f prime of 3? It is 5. So our answer is 1/5. The only time it doesn't is if, like, let's say this was f prime, like, say the derivative was 2/3. If you got 1 over 2/3, then you want to flip the second and multiply. So then we would get like 3/2 in that case. So if you get a whole number for your derivative, then you're going to have a 1 on top. If you have a fraction, you might end up with something that doesn't. No, because if I had like 1 over 1/2, well, let's just do the next problem. I'll show you why in the next problem. Okay.
The 8 and the 3 and the 5.
So when I'm finding the inverse right here, so this is telling me I need to find the inverse of 8. So like in our, whenever we find inverses, and you missed this part yesterday, we did it in pre-cal, but it's been a while. So if we want to find inverses, we switch our x's and y's, right? So like if a function has the point 3, 8 on it, the inverse would have 8, 3. You switch the x and y's. Yeah. So in the original function, this is 3, 8. So in the inverse, 8, which was the y, is now the x. So like, yes. Yeah. So this is going to be 3, and then f prime of 3 just equals 5, so it's 5 there. So it's the same thing on number 2. We're using that same formula, f inverse prime of, in this case, we're doing -2, right? So it's going to equal 1 over f prime of f inverse of -2. So we got to start finding that inverse. What is that inverse going to be? Okay, 6. And you almost, like, at this point, like, there's not a lot of options to choose from. This is the derivative, so in it doesn't have anything to do with the derivative. It's probably not going to be itself most of the time. The only other number you see there is 6, although we'll see on the table problems how they get around making that super easy. And what is f prime of 6? 1/2. Now, watch this. We got 1 over 1/2. Dividing fractions, easy as pie. Flip the second and multiply. In this case, we're going to get 2 over 1, but 2 over 1 is just 2. So it can end up being a whole number. Okay? I have seen AP problems that were like this, but what you're more likely to see is a problem that looks like this. Okay? So it's really the same type of problem, But instead of giving you just a couple pieces of information, they give you a whole table of information. So you've got to choose. It's more difficult to find what you're looking for here. But it's the same process. So in this case, they're calling G and F inverses. And they're asking for G prime. So when they ask for G prime of 3, we have to remember that G is my inverse. If you don't like that, change it to inverse notation there. But it's going to be 1 over F prime of G of 3. And G here is your inverse, so you could replace that with an F inverse there if you needed to. So notice on the table, does the table tell us anything about G? No, it's only about F. So we can't just read it off of the table like we normally would. We know G is the inverse. So what is the inverse of 3 going to be? I think I heard somebody say it right. It's 1. Okay, so we don't look at this column right now. We don't look at this column for the inverse or the derivative at all. So we ignore that. We are looking at the y column. F of x is like your y coordinate, right? This is for f. This is the original function. So we want to know where the y is 3. It's right here. And it's going to be the x that goes with it. So it's going to be 1. So we got G of 3 is going to be 1. 1 over F prime of 1. Okay. This is similar to the way we just did it. When I see x equals 1 and f of x equals 3, that tells me f of 1 equals 3. Alright, so the 3 is your y, so the x that goes with it is your inverse there. Okay, then f prime of 1, I'm going to erase my scribble over here. Now we want to look at this derivative. So what is f prime of 1? Is 2. So our answer is going to be 1 over 2. So 1/2. Okay, questions? Try that next one on your own. Freeze it. Alright, let's see. Noah, tell us what to do.
Alright, so first, we got G of 6.
Okay, so I'm going to write like this. We got f prime of G of 6. Oh, still frozen. Hit the button. There we go. Okay. Alright, what is G of 6, Noah?
2.
Okay, is he right?
Yeah.
Okay, good. Alright, then?
And then that's just 1 over 1/2,
Which equals 2 when we flip and multiply. Very good. Okay, questions? Alright. This really should say 8 right here on this side. Alright. Okay. So, something like this, they might put on the AP exam too. I would say the last problems we just did are like what you typically see. But I have seen ones like the first ones that we did. I have seen ones like these before. And these are just confusing because this year amount of numbers and rows and things to look at. So for G inverse of 5, first of all, you got two functions here. You got f and g. F and g are not inverses of each other this time. Nowhere does it tell you that f and g are inverses. So if that doesn't say f and g are inverses, you can't assume that f and g are inverses. They are not, or may not be in this case. So G inverse prime of 5 is going to equal 1 over G prime of G inverse of 5. All right, so we got to find that G inverse of 5 first. Okay, it does help there's only one 5. It's right here, right? And that is where we want it to be because it's our G of X column, right? And we're looking for the X that goes with it, which is up here, which is 0. So G inverse of 5 is 0. So we got 1 over G prime of 0. What is G prime of 0? Okay, X right here, we're looking at the G prime row, should be 6. So 1 over 6. That's not G prime times 0, it's G prime of 0. So you're not multiplying it by 0, but you are finding G prime of 0. Okay, questions? All right, 6. So when you're looking for X coordinates, right here's your X coordinate, which is 0. And then you see that G prime is 6 there. All right, now, example 6 is not an inverse problem at all. I've put it here because a lot of times you'll get questions like this that'll use a table, and they might ask you 2 or 3 questions from that table. And some of them might be inverses, but not all of them. And you're going to see that on the worksheet that you guys are going to do today also. So for this, K is F over G, and I need to find K prime of 2. So what do I need to do for this problem? Quotient rule. So K prime. All right, this is important right here. If you see this on free response, you have to show that you did quotient rule. So you can do that by doing K prime of X and have everything having X's, and then you can plug stuff in. Or if you want to sort of shortcut it, you can do it by doing K prime of 2, but don't plug any numbers in yet if you put the 2 there. So you either need to have the whole expression with X's, or you need to have it like not worked out yet. So like I prefer to do it that way with the 2's already in. But so it'd be G of 2 times F prime of 2 minus F of 2 times G prime of 2 over G of 2 squared. You can plug the 2 in as long as you still have all your F and G's. So it is okay to do this as long as you have your F and G's. Or you could have X's everywhere I have 2's right now. But what I don't want you to do is say K prime of 2 equals, and then start grabbing stuff from your table without labeling it F and G's and all of that. So we got to find all of the stuff from our table. What is G of 2? 1. So we're always looking up here where on the X, we go down to the G column, it is 1. Times what's F prime of 2? Negative 1 minus F of 2, which is, what is F of 2? 2 and g prime of 2. 0 all over g of 2 squared, which is just 1 squared. Alright, so we get negative 1 minus 0 over 1, so we're going to get negative 1 for our answer here. You'll see some of these today on your worksheet that don't involve inverses at all, so know that they'll be there some too. Try 7 and 8 on your own. On this, did you do 2 times 0? Okay. Remember, you got multiply for that. So product rule, it's got your x times the derivative of f plus f times the derivative of x. The derivative of This was a minus right here. You need a minus right here, which means you're going to be subtracting.
Wait, if I could do it, you could do it.
Because you either have to show like h of h prime of x equals g prime of x, blah blah blah, or you have to say h prime.
What did you get? Tell me. 3.
I was only looking at this one. Sorry.
You have to make sure you plug it right.
You're taking all of this stuff right here. You need to around this if you have it.
It's kind of sickening how that X works. Because in the first bit, it's just negative 1. But then you take the derivative of the X itself.
Positive, you got the negative, but you also have to distribute that negative back.
Did you say it's so free? Great.
So like right here,
It is.
you need, when you do this, you need like brackets around this stuff right here. Like when you're taking the derivative of this stuff, you need like brackets. So we have to distribute that negative to the end. Plug in a negative 1 for your x. And g of negative 1 is not 0. Oh, wait, it's got to be g prime. So you're taking the derivative here. So like when you take this derivative, it's separated by minus sign. You just take the derivative of g. Well, what you want to do is take the derivative. That's what you were doing here. Right? But add you're taking, you just want to take the derivative of this expression. So when you take the derivative of this, the derivative of g is just g prime. And then right here, you got to use the product rule, which you did. So you were taking the derivative here. Yeah, you only took the derivative here. All right. You did put the negative 1 there, but you should get. Oh, maybe it is. Oh no, because you're doing g prime of negative. When you put the negative 1 right here, yours is a little. you got to hold on to these parentheses that you got right here, Thomas. So, I had already let you mess it up before. So go ahead and put the negative 1 right here now. Before you get to this. And then so you'll combine everything here, and then you're subtracting it, so it ends up being like 1 minus 6 there. And you're multiplying right there, so negative 2 times negative 1. Alright, so right here, negative 2 times negative 1 is a positive 2, right?
And then it goes back to negative.
But if you have this negative, you got to distribute it to both of them, so go back to negative, giving you a negative 6. Negative 6. Yeah, or what I would do is I just do 4 plus 2, which is 6. And you go 1 minus 6. Yeah. Order of operations is getting us there. Okay. So here is 7 and 8. Look at it, see what questions you have. Should get negative 1/2 for the first, or for example 7, and negative 5, for example. So make sure you use product rule on that second part. And, so like I know Jack's was not right. Jack, you either have to show this line right here, or you can show this line right here instead. You don't have to show them both. But you got to have one of those expressions where you're showing the f and g primes before you start plugging numbers in. Unless it's multiple choice, and then it doesn't matter. But if it's free response, you got to have one of those 2 lines right there. So you can join the coalition to not show work with Daniel over there, and protest this if you want, but I don't think we'll get far.
Again, just guessing with the numbers on the table.
Daniel and Jack can be outside of the classroom with signs of just like crazy math with no work shown, protesting this decision, but you have to show them. All right, so here is your assignment.
Pain that I have the staple in it, meaning that it's more than just one page. Loki, how big of this paper is thick?
One of the reasons that it's so long is that 6 through 18 are all multiple choice. They take up more space. Yes. 1 and 3 and 5. 1, 3, 4, and 5 are more like from the homework than from these. So we need to work that first one together, maybe. Okay, let's do that first one together because it's more like what was from the homework. And I know we should have done some more problems yesterday. So we've got f of x equals 2x cubed minus 3x. H is the inverse of function f, inverse function of f. Then we want to find h prime of negative 1. So h prime of negative 1. The formula tells us that it's going to be h here is the inverse. So that's like your f inverse. So it's f prime of h of negative 1. Yes. So here, The reason it's different is because h is our inverse of f. So h is like the g that we used earlier, or the f inverse that we used earlier. So if you don't like that notation, you can always just say that h equals f inverse of x. So we could just write 1 over f prime of f inverse of negative 1 here if we want. If you prefer that notation, there it doesn't matter which one you use. Okay, so the first thing we have to find, just like our table problems, is we got to find h of negative 1, or that's our inverse at negative 1. With a table, we would just go look for where the y value was negative 1, and we'd find the x that goes with it. We don't have a table, we have a function. So what are we going to do? This particular one we can't find the inverse of. So while you can do that on some problems, we're going to put the negative 1 there for the y. And then we're either going to go ask Coach Wood how to do synthetic division, or we're just going to guess and check. I do know how to do synthetic division, but they're telling me one's working, so it's usually one that's pretty simple. So this is going to be 2 minus 3, which is negative 1, so that works. So 1 was the inverse, so I got 1 over f prime of 1. And then if this was on a table, I would just look at the table, see where x equals 1, I'd find f prime. But we don't have a table. What do we have instead? We have the equation, so can we find f prime? Yeah. Very good. What are we going to get for the prime of the f of x? We'll get 6x squared minus 3. And when we plug in 1, we'll just get 6 minus 3. So Logan is correct. We will get 3. So we will get 1/3 for our answer.
And you said 3 and 5 are also
3 and 4 and 5 will be like that. So I'm going to let you guys work.